We are talking about piecewise defined functions, and I am going to start by making XY tables for the different pieces. And so remember, this is like y equals x minus 5 for in between -5 and 2. So I'm going to start by making an XY table for y equals x minus 5. And I'm going to choose the endpoints to be x values on my XY table, and then I can put whatever I want in between. The less than or equal to tells me that this is going to be a solid dot. And again, on this side, less than or equal to also tells me solid. They don't always have to be the same, but in this case they are. So I like to write myself a little note there just to make sure that I know. And then when x is -5, I have y equals -5 minus 5, so that's -10. And then I can just choose some other points in between -5 and -2. So I put -4 in for x, I get y to be -9. And when I do -3 in for x, -3 minus 5 is -8. And -2 minus 5 is -7. So I can go ahead and graph these points on my graph. -5, -10, and that is a solid dot. And -4, -9, -3, -8, and -2, -7. So that is the end of that piece. I will connect them because I could have put x values in between those. And now I'm going to choose a different color for the second one. Oh, that's my Galaxy pen. I don't know how to add another pen. Oh, there it is. Okay, I'm learning, guys. So I'm going to add another pen, maybe blue. And so in blue pen, I will do the next piece, which is y equals x squared. So because remember, f of x is really the same as y. So I could have just turned this into y. And so for this one, I'm going -2 to +2. But those, because it's less than and not less than or equal to, those are going to be open dots. And so from -2, -1, 0, 1, 2, that one's also an open dot. So -2 squared is +4, -1 squared is +1, and then 0, 1, 4. So I'll come over here, and now I got to make sure I make this an open dot. -1, 1, 0, 0, 1, 1. Obviously, this is going to be a parabola shape because that is what the y equals x squared gives us. Try that again. Okay. And then the final piece is going to be, let's do green. The final piece is going to be this y equals 2x plus 1, which keeps coming up in our notes. And so for that one, I'm going from 2 to 4. So I only have these 3 points on it. And 2 is solid and 4 is solid because of the less than or equal to. So those are both solid points. So if I put 2 in, I get 2 times 2 plus 1, that's 5. 3 times 2 plus 1, that's 7. And 4 times 2 plus 1, that is 9. So I go 2, 5, that is a solid dot. And 3, 7. And 4, 9, that is a solid dot also. And then I can connect them. I don't know what just happened, why my dots disappeared. Okay, so now you can see that our piecewise has 3 pieces. And so that is how we graph them. But now the domain and range are going to be a little bit different. So for domain and range, remember I'm going to look at left to right and low to high. So for domain, I start at -5 and I have a filled in dot, and then I go to -2, and then I have an open dot at -2 that goes left to right to +2, but then I have a filled in dot at +2 that goes, whoops, to a filled in dot at 4. So my domain does go directly from -5 to +4 with square brackets because both of those are included. Now my range is going to go low to high. It's going to start low at -10 and it will go up to -7. And then it's got a big jump and it goes from 0 up to an open dot at 4. And then it goes from 5 up to 9. So the range is actually going to be 3 pieces. So for the range, I need to write it from low to high. And so for the range, I'm going to write the range down here because I don't feel like I have room up there. So for the range, I'm going to go from -10 to -7, and both of those are square brackets. And then I'm going to go from 0 with a square bracket to 4 with a round bracket because it's a hole, and then my U, and then my square bracket 5 to square bracket 9. So remember, these filled in dots and open dots, these points and holes, can help you figure out what your brackets should look like for the domain and the range. Okay, and then the last bit is going to be to evaluate. So I'll just move this guy up here. And so remember with evaluating, you are just going to think about the point. So remember that this f of x is y goes with this point x comma y. So when it was 0, we had our blue pen, our blue graph, and we had the point 0, 0. For f of -3, that was on the red one, and that was -3 right here, so -8, because we have the point -3, -8. For +3, we are in the green graph, the green piece of the graph, and that was up here at 3, 7. So f of 3 equals 7. F of 9, all the way out here, I don't have any kind of point. So that is undefined because there is no point. And then f of -1, that's going to be my blue piece, -1, that is at +1 because of the point -1, 1. And then finally f of 2, although you think it might be blue, it's actually in the green because it's a hole for the blue. It's undefined in the blue, but it's defined in the green at 2, 5. So this should all be green. It's up here. I don't know why that erased it. That was weird. And so that is how you do piecewise defined functions.